You've heard Billie Eilish's song about it, but what actually is dark matter? Is it a threat or just more space stuff we don't understand? Well, let's unpack this, and I'll try not to make it too dark. Now, before we get into the nitty-gritty, here's a little disclaimer. No one knows what dark matter is, but there's so much of it out there that it can't all be made up. So if you hear anything in this video that you think is wrong, please let us know it in the comments below so everyone can learn. Okay, now that we've got that out of the way, let's start at the beginning. You know how when you're watching TV you have to deal with commercials? Well, the universe works the same way. It comes with an invisible package deal of things we can't see but affect what we do see, like dark matter. Everything we see around us makes up only 10% of the universe. Stars, planets, black holes, even you and me. Everything we know of, all the stuff that physicists call normal matter, that's only 5% of the pie. What's the remaining 85%? Mostly dark energy, which we also don't really understand, but that's a story for another day. Dark matter is the focus today. And dark matter is 27% of the universe, so where is it? All around us, including between the stars. In fact, according to our best measurements, most of the mass in space is dark matter. It's everywhere. Dark matter is all around you right now, passing through your body, completely invisible and undetectable. You might reach out and touch it, but you wouldn't notice it any more than you notice the air molecules you breathe, and yet it's there. But how can we be sure it's there if we can't see it? Well, it's kind of like if you were in an empty swimming pool and you saw ripples moving across the water. You would know something was disturbing the surface even if you couldn't see what it was. That's because the movement of the water tells you something is there. In the same way, dark matter's presence is revealed by the effects it has on other things. Like a heavy weight in a galaxy affects how fast other objects move around it due to its gravitational pull. We see similar things happening in space. In the 1930s, the Swiss astronomer Fritz Zwicky was observing the Coma galaxy cluster. He noticed that the galaxies within the cluster were moving too fast. According to physics, those outer galaxies should have long ago flown apart, but something unseen was holding them together. His hypothesis, there was some sort of invisible mass surrounding the galaxies, holding them together. Physicists originally thought this unseen mass was just regular matter that hadn't been seen. They called it dark matter. Now they think there's probably more dark matter than normal matter in the universe, but it's not that easy to spot. It takes special equipment to detect dark matter. Even then, it's hard to say exactly what's going on. For example, there are experiments like XENON1T, which is an experiment designed to catch dark matter particles. Located in Italy's laboratory Nazionale del Gran Sasso, it's one of the deepest underground labs in the world. Why? Because dark matter particles are weakly interacting, meaning they're extremely elusive. They're also massive, hence the name massive. They might interact with ordinary matter so rarely that if you tried to detect them with current technology, it would take longer than the heat death of the universe for you to get a result. To increase their chances of getting a hit, scientists are conducting experiments deep underground to avoid interference from cosmic rays and other background radiation. They're searching for a specific type of interaction, the scattering of an atomic nucleus, which leaves behind a telltale flash of light and a small amount of heat. If this happens, it might mean a dark matter particle passed through the detector. However, sometimes radioactive elements like potassium in the soil can mimic these signals. So scientists have to meticulously calibrate their experiments to rule out false positives. What they want to do is build a map of dark matter. Right now, they have points of data, but they need to connect the dots. Also, there are a lot of theories about what dark matter might be and how it might interact with our universe. One idea is that it's made up of particles that barely interact with normal matter or light. These particles, called WIMPs, or weakly interacting massive particles, are hypothetical and have never been detected, but that doesn't mean they don't exist. Another idea is that dark matter is made up of tiny ultralight particles called axions. They would interact with normal matter in different ways than WIMPs, leaving behind different signals in experiments like XENON1T. Some scientists think dark matter could be made of something else entirely. A few believe it's made of nothing, that is, it doesn't exist. Instead, they think our understanding of gravity is wrong, and what we observe is actually modified gravity. And what about those black holes people keep talking about? Some scientists think black holes might play a role in dark matter. You see, black holes are regions in space with gravity so strong that not even light can escape their grasp once it crosses a certain point of no return, called the event horizon. Black holes are invisible, but they have masses many times greater than our sun. Could it be that these massive invisible objects make up part of the dark matter? Well, maybe. Some research suggests that there could be a connection between dark matter and black holes. Others suggest that dark matter could form around black holes, or that they might even be related. But these ideas are highly speculative and far from being proven. So is dark matter a threat? It depends on what you think dark matter is. If you think it's made of something dangerous, like a black hole, then yeah, you might be in danger. But if it's just an unknown substance, it's not going to hurt you. Besides, even if we found it, it wouldn't change much. Sure, it would revolutionize physics, but you'd still be able to watch YouTube videos and eat cheese. However, if we discovered that dark matter wasn't made of anything at all, that it was basically an illusion caused by a breakdown in our understanding of gravity, that would be truly mind-boggling. Such a discovery would shake the foundations of physics as we know it and force us to completely rethink how the universe works. It would raise more questions than it answers. For instance, if dark matter doesn't exist, why do galaxies rotate the way they do? And why do they seem to hold themselves together? Is there some other force at play that we haven't yet discovered? Or is there some aspect of gravity that we don't understand? Perhaps dark matter is something else entirely, like a type of negative mass that repels instead of attracts. Or maybe it's made up of particles from another universe, a parallel dimension that bleeds over into ours. Maybe you felt it, that one time you walked through a door and suddenly everything seemed different. Yeah, that could be dark matter. Of course, this is pure speculation. We don't really know what dark matter is. But what we do know is that there's something out there that we can't see, something that affects how things move in space, something that makes up a quarter of the universe. The search for dark matter is one of the biggest mysteries facing physicists today. It could lead to a revolution in our understanding of the cosmos, or it could end up being a dead end. Only time will tell. So here's what we want you to do. Go outside and look up at the stars. Then come back inside and watch the rest of our videos. Thanks for watching.